Next, let's talk about properties of the derivatives. So if we have u of t and v of t, and those are vector-valued functions, and c is a constant, and f of t is a scalar function, which remember scalar function means it's f of t produces a scalar, not a vector, then the derivative with respect to t of u of t plus v of t is just u prime of t plus v prime of t, something you should expect. Similarly, the derivative with respect to t of c u of t is equal to c u prime of t. Have our product rule when it comes to f of t being a scalar function. d dt of f of t u of t is equal to f prime of t u of t plus f of t u prime of t. Now, what happens if we have a dot product between two vector-valued functions? Then the derivative with respect to t will be u prime of t dot v of t plus u of t dot v prime of t. Now, what if we take the cross product and take the derivative? Then we have u prime of t cross v of t plus u of t cross v prime of t. Now, particularly this one, we want to be careful here because remember, cross product is not commutative. U cross v is not the same as v cross u, and so we want to be careful with how we do our u prime cross v of t and our u cross v prime of t. Notice this dot product, this should be a v right there. So once we've added multiplication of vectors with our dot and crosses, it should look very similar to all the product rules that you might be familiar with, but with some adaptations because of the dot product and the cross product. And finally, we have a chain rule in the sense of a scalar function. We have u of f of t is equal to u prime of f of t times f prime of t.